Okay, this is 7.4, solving absolute value equations. But let's first start out by reviewing what absolute value is. Absolute value is the distance a number is from zero on a number line, and absolute value is always positive. Okay, so if we think about a negative number like negative 3 is the same distance from zero as positive 3. Okay, and that's what absolute value refers to. Okay, is just the distance from zero, and distance can't be negative. That's why it's positive. We denote absolute value by these two vertical bars. So if I ask you what this is saying what is the absolute value of negative 3, which is positive 3. Okay? A lot of times students make mistakes and they just think that they're opposites, but it's not the case. It's just always positive. So the absolute value of positive 3 is also positive 3. Okay, one way I like to think about this is make the analogy of a washing machine. Okay, so think about the absolute value bars as a washing machine, and negative numbers are your dirty clothes. You put in dirty clothes into the washing machine, they come out clean or positive, but if you put in clean clothes or positive numbers, they still come out clean. Okay, so hopefully that helps keep it straight. All right, so let's look at some actual equations here. Okay, so this first example, we have the absolute value of y is equal to positive 8. Okay, so we know that the absolute value of negative 8 is equal to positive 8, and so is positive 8. So what could go inside here is both negative 8 and positive 8. So those are your two values for y. All right, what about this next one? The absolute value of p is equal to negative 6. Well, remember, absolute value is always positive, so nothing can come out of these absolute value bars as a negative. So if you see something like this, we just write no solution. All right, let's look at this next one. We have the absolute value of 2x minus 3 is equal to positive 5. All right, well, first of all, let's just think about what could come out of these absolute value bars and get us the answer of positive 5. Well, we know that the absolute value of positive 5 and negative 5 would come out of the absolute value bars as positive. So what we do with an absolute value equation is we set up two different equations. Okay, the first one, we simply remove the absolute value bars. Okay, and then the second one, we keep the same thing, we just set it up equal to the opposite. So instead of positive 5, set it up equal to negative 5. Okay, and then we just solve both equations. So there's two values of x, just like there was with our first example. All right, and we're going to solve them the same way. We're going to add 3 on both sides. And then you're left with 2x is equal to 8. Then divide by 2. You've got x is equal to 4. And then we solve the next equation, which is the same way. Add 3 on both sides. Left with 2x is equal to negative 2. Divide by 2 on both sides, and you're left with x is equal to negative 1. So those are your two values of x. All right, so I've got some steps for solving absolute value equations. So step 1, move everything outside the absolute value bars to the other side. Then step 2, set whatever is inside the absolute value bars equal to itself and its opposite. And then 3, solve both equations. All right, and I always like to throw in like a step 1.5. Step 1.5 is to check if there will be a solution. So write that down, because if we get to the point where we have an equation like x minus 4, absolute value of x minus 4 is equal to a negative number, like negative 10, well, nothing can come out of these absolute value bars as negative 10, so this would be a no solution. So this will save you some time if you stop yourself after step 1 and just make sure you will have a solution to your problem. All right, so let's take a look here at this example. We have 2 times the absolute value of x minus 8 plus 5 is equal to 15. So as step 1 tells us, we need to remove everything outside of the absolute value bars, okay? And so we want to solve this kind of in reverse GEMDAS order, right? If we were solving out a math problem, we would have to follow this order: grouping symbols, exponents, multiply, divide, add, and subtract. We want to solve using inverse operations going the opposite way, okay? So what I have here is multiplication here, 2 times the absolute value of x minus 8, and then I have addition here, right? So I want to do the opposite. I want to get rid of this 3 by subtracting, and then I will divide by 2. Okay, so I'm going to do this, subtract this 3, get it out of here. Now I'm left with 2 times the absolute value of x minus 8 is equal to 12. And now I want to get rid of this 2, so I'm going to divide it. And that is equal to 1, so it's essentially gone. We don't need to write anything like that. And 12 divided by 2 is 6. All right, now step 1.5, so we just removed everything outside of the absolute value bars. Now we want to check, is there going to be a solution? Yes, there will, because that is positive, not negative 6. So now we can set up 2 different equations. The first one, we simply remove the absolute value bars. The second one, we keep the same as the first equation, but we set it to its opposite. Set a positive 6, negative 6. And then we just solve both of these equations. So we're going to add 8, and we're left with x is equal to 14, or add 8 on both sides here. Negative 6 plus 8 is positive 2. So there you go. There's our 2 values of x. All right, let's look at a few more examples here. We have the absolute value of x plus 5 minus 8 is equal to 15. So let's remember step 1, remove everything outside the absolute value bars. So that means this negative 8 has got to go. How do I get rid of it? I'm going to do the inverse operation and add 8. If I add 8 on both sides, it will eliminate on the left side. So I'm left with absolute value of x plus 5 is equal to 23. Right now, check to see if there's a solution. Yes, 23 is positive, so there will be a solution. So we're going to now set up 2 different equations. First one, simply remove the absolute value bars. Second one, keep the exact same as the first one, and then just switch the answer to a negative. All right, and then we just solve both of these. We're going to subtract 5 on both sides, and I'm left with x is equal to 18, or subtract 5 on both sides, and x is equal to negative 28. All right, this next example here, we have this 4 and 2. Now, a lot of students will go, oh, 4 and 2, that's 6, and maybe they'll subtract that 6 or try to divide that 6. These are separate things. Right here, this is 2 times the absolute value of 3x, and this is then add 4 to it. So they're separate things. So I first need to subtract the 4 out, and then I want to get rid of the 2 by dividing. I'm going to first subtract the 4. All right, so I'm left with 2 times the absolute value of 3x is equal to negative or positive 24. And then we divide by 2. And so now I'm left with the absolute value of 3x is equal to 12. All right, so now we've removed everything outside the absolute value bars. Is there going to be a solution? Yes, there is, because this is a positive 12. So now I set up 2 equations. 3x is equal to 12. Just remove the absolute value bars and set up the same thing equal to the negative. All right, and we're going to solve these the same way. Just divide by 3. And so I'm left with x can either be positive 4 or negative 4. All right, moving on. Here we have this ugly one with some fractions, but let's see how it works out. So first thing we want to do is add 8. It's an ugly 8. Add 8. Do it to one side, got to do it to the other side. Cancels out. This is equal to 20. Let's drop down everything else. All right. And now I need to get rid of this negative 5. So I divide by negative 5. I do it to one side, I got to do it to the other side. So now I'm left with the absolute value of 3/8 x minus 1/6 is equal to negative 4. So we've just done step 1. Now we should do step 1.5. Check to see if there's a solution. Ooh, there is not going to be a solution because this is a negative number. So nothing can come out of these absolute value bars as negative. So your answer is no solution. All right, now let's look at the story problem we got here. At the start of the season, Mr. Sullivan has to make sure that all the basketballs are inflated correctly. They must be 9 pounds per square inch with an error of 0.5 psi. What is the maximum and minimum possible psi for all the basketballs? All right, so first what we have here, the error of psi, this is called the absolute error. All right. And so we know that this needs to be plus or minus 9, right? So the possible values of PSI would be 8.5 or 9.5, right? It could be either off a little bit less or a little bit more. So these are our two options. So how do we set up an equation to get us these two values? All right. So we want to set this equal to the absolute error. So that's going to be 0.5. And we're going to set this up as the absolute value of x minus 9. And so you'll see why it's minus in a second. So we don't have anything to remove outside the absolute value bars, so we can just start. Let's check, is there going to be a solution? Yes, the 0.5 is positive, so there will be. So we're going to set up two equations. X minus 9 is equal to 0.5, or x minus 9 is equal to negative 0.5. All right, and as you see, when we solve this, when we try to isolate x, we're going to add 9, and that's why it's negative in the absolute value bars. So then when we do that, we get x is equal to 9.5, and when we add, 10. When we add 9 on the other side, we get x is equal to 8.5. All right, almost done here. Just got a couple more sample problems for you guys. I want you to pause the video and give these two problems a shot. All right, let's see what you came up with. So step 1 is done for us. We have nothing outside the absolute value bars, so we can just set up two equations. First one, simply remove the bars. Second one, set it up same, just equal to its opposite, and we solve. Add 1 on both sides. 3x is equal to 14. X is equal to 14 over 3. I'm just going to leave that as an improper fraction. And I'm going to add 1 here, add 1 here. It's going to be 3x is equal to negative 12. Divide by 3, we get x is equal to negative 4. All right, there we go. There's our two options for x. All right, moving on to this next one. Hopefully you didn't just see this negative 15 and write no solution, because we first need to remove everything outside the absolute value bars before we check to see if there will be a solution or not. And I'll show you why here. So first of all, we have negative 5 times the absolute value of x plus 3, and then we have minus 3. So the first thing we want to do is get rid of this negative 3. So we're going to do so by adding 3 on both sides. This will eliminate on the left side, and I'm left with negative 5 times the absolute value of x plus 3 is equal to negative 15 plus 3, would be negative 12. And now I need to get rid of this negative 5, so I'm going to divide by negative 5. If I do it to one side, I need to do it to the other. So divide over here as well. This equals positive 1, so it's essentially eliminated. And negative 12 over negative 5 is going to be a positive. So let's convert that to a decimal. That's going to be 2.4. All right, so now we've removed everything outside the absolute value bars. Now we can check to see if there's going to be a solution. 2.4 is positive, so there will be. So we can set up two different equations. First, simply remove the bars. Second, keep the same as the first one. Set it up equal to its opposite and solve them both. This one's a pretty easy one. We're just going to subtract 3. So I'm left with x is equal to negative 0.6, and subtract 3 on this one on both sides. X is equal to negative 5.4. All right, that's all I got for you guys. Why don't you give the practice problems a shot? If you need help, come see me. Good luck.